Functions that model inverse variation have the form f of x equals a over x, where x does not equal 0. They belong to a family whose parent is the reciprocal function, f of x equals 1 over x, again where x does not equal 0. Take note, key concept. General form of the reciprocal function family. The general form of a member of the reciprocal function family is y equals a over the difference x minus h plus k. Where x does not equal h, that would lead to a 0 denominator. The inverse variation functions y equals a over x are stretches, shrinks, or compressions, and reflections of the parent reciprocal function, depending on the value of a. The graph of the parent reciprocal function y equals 1 over x is shown at the right. We'll see some key details of this graph, its asymptote locations, on the next slide. First note, we have a vertical asymptote, the y-axis, or the line x equals 0, and we have a horizontal asymptote on the x-axis, or the line y equals 0. Problem 1. Graphing an inverse variation function. What is the graph of y equals 8 over x, where x does not equal 0? Identify the x and y intercepts, and the asymptotes of the graph. Also, state the domain and range of the function. In step 1, we'll make a table of values that includes positive and negative values of x. On the left are negative values of x and the y's associated with those, negative 16, negative 8, negative 4, negative 2, negative 1, and negative 1/2, when substituted into the function, yield a y value of negative 1/2, negative 1, negative 2, negative 4, negative 8, and negative 16. For selected positive values of x, 1/2, 1, 2, 4, 8, and 16, we find associated, or related, y values of 16, 8, 4, 2, 1, and 1/2. In step 2, we graph the points. Here they are graphed. First, notice how the y values get closer to 0 as the absolute values of x get larger. So as we move farther to the right on the graph toward positive infinity, and also as we move farther to the left toward negative infinity, our points draw nearer and nearer to the x-axis, our horizontal asymptote. Something similar occurs as we work toward positive infinity in the upward direction and negative infinity in the downward direction. Our points draw nearer and nearer to the y-axis, our vertical asymptote. Step 3. Connect the points with a smooth curve. X cannot equal 0, so there's no y-intercept. So be careful when graphing that your line doesn't actually intersect the y-axis. The numerator is never 0, so y is never 0. It means there's no x-intercept. So again, be careful that your lines never cross the x-axis. The x-axis is a horizontal asymptote. The y-axis is a vertical asymptote. Knowing the asymptotes provides you with the basic shape of the graph. The domain is the set of all real numbers except x equals 0. Note the graph is not defined for x equals 0. The range is the set of all real numbers except y equals 0. Note the graph is not defined at y equals 0. Your turn, part A. What is the graph of y equals 12 over x? Identify the x and y intercepts and the asymptotes of the graph. Also, state the domain and range of the function. And part B, a reasoning item. Would the function y equals 6 over x have the same domain and range as y equals 8 over x, or y equals 12 over x? Explain.